I'm Jonathan Tomkin from the University of Illinois. This week we're going to start with a question. Are whales a sustainable source of energy? For a long time they were a leading source of light in American homes. This is because whale blubber can be rendered down into an oil that provides a clear, bright light. So oil prospecting in the 19th century was a really tough job. You needed a really big boat and a really sharp stick. These boats would go out for months, even years at a time, hunt whales and render them on their decks. This production of oil is in some ways renewable because whales reproduce. However, just as we saw in the fisheries example, it's possible that you could over-harvest whales and thereby destroy the resource. And of course today we have moral issues with hunting whales in many countries. Even though oil is in principle a renewable resource, oil production from whales peaked in the 1840s and then declined. It didn't decline for the reason you might think. Although the number of whales had fallen by perhaps a third, the fall hadn't been catastrophic enough to explain why the US shifted away from using whale oil as an energy source. It turned out there was a much easier way of getting oil. Oil out of the ground was much cheaper because it was much easier to get. You need to drill a hole and then the oil would, in many cases, just spurt out of the ground. So you didn't need to have a boat, you didn't need to have large expert crews, and it wasn't such an enormous undertaking. What's more is that this oil could be refined to give an even brighter, cleaner light than you could get from rendering whale blubber. So just as we saw peak oil in whales, some are suggesting that we have peak oil in fossil fuels. Does this mean we'll have to go back to whales in the future? Let's examine the importance of oil in the modern economy. Oil use has been growing strongly over the last century. This is because oil is such a useful resource. It's energy dense. This is why it's so important in transport. We can carry it with us and burn it when we need it. Let's revisit this graph. It can be hard to see, but 94% of all energy used in transport in the United States comes from oil. So imagine your country without oil. In the United States, 94% of the energy used in transport comes from oil. If we ran out of oil today, we'd have to make a massive change to our society to accommodate the new social systems that would arise. So it's a very important question then. Are we running out of oil in the foreseeable future? And this goes beyond the worries about changes to the atmosphere from the burning of fossil fuels and the production of carbon dioxide. Because right now there isn't a good replacement for oil in our transport systems. We do know that many places around the world today are producing far less oil than they did in the past. There's a geologic reality to where the oil is. You wouldn't guess that in the 1960s, the United States was the world's biggest oil producer. In the continental USA, that is the lower 48 states, we're producing around half as much oil today as we did back in the peak. Similarly, Alaska is also below its peak, and again by about 50%. So in the United States, despite increasing demand, there's been decreasing production. That's partly because there's only so much oil available. There's only so much that we can suck out of the ground. Let's look at a couple of examples. Here are the two biggest oil-producing states in the United States, Texas and Alaska. In the early 70s in Texas, we saw a peak in production, and since then we've seen a steady decline. Notice how similar the curve is in Alaska. The peak was later, in the 80s, but nevertheless, Alaska is producing much less oil than it did. This particular shape has been observed in many places around the world, and it's sometimes called Hubbert's Peak, or as we'll normally refer to it in this lecture, as peak oil. So the idea is that oil production increases over time as more exploration takes place and more exploitation of the resource takes place. But as the oil reserves are removed from the system, that is, they're used up, the amount that can be extracted declines. So peak oil, sometimes known as Hubbert's Peak, is the point at which there is maximum extraction. if we have a very symmetrical curve like this, it's actually also the point at which half of the oil is extracted. So there's still a lot of oil to be left in the ground, if you like. There's still a lot of oil to come out. But after peak oil, we will never extract it at the same rate as we did before. The US oil production curve follows this peak oil model quite well, as you can see from this image. Peak oil occurred in 1971 in the United States, so that's over 40 years ago. What about the rest of the world? The peak oil model also appears to do a good job of describing Norway, which started producing oil much later than the United States. They peaked just after 2000 and are now declining. Maybe you come from an oil-producing nation. If you look at this graph here, you should be able to find it, or indeed if you're from Alaska or Texas, your own state. According to the US government, total oil production has been remarkably flat in the last few years. So many people have said that this looks like a peak oil event. Many individual countries have already experienced peak oil, as we've seen. But if the whole world is experiencing peak oil, does this mean that we'll have a decline in the future? In 2004, the US government predicted that by today we would see a significant decline in oil production over the last decade. Is this what we actually saw? This decline since 2004 didn't actually happen. Instead, production has been relatively flat. So this is not quite the peak oil model. We're seeing a plateau of oil production. In fact, last year was the biggest year of oil production on record. So if peak oil is to occur, it didn't occur back in 2004. Consumption, of course, has also been up globally as well. But notice that Europe and North America are actually using less now than they did in the past. And again, North America has an increasing population. So, although peak oil has some evidence, we also have to be careful when we use it. When Hubbert first proposed it, he thought peak oil would occur sometime in the 1990s. Stop and take a minute to write down as many ideas as you can as to why we might keep reaching new peaks, why we haven't achieved peak oil yet. One of the things that you might have said is uncertainty about reserves. What's interesting, of course, about oil is that it's very hard to see. It's trapped underground. But recent advances in our ability to image the Earth has increased our ability to find oil. Also, recent technological advances in the way that we can extract oil means that oil that used to be too hard to get, for example, deep offshore or trapped in unconventional sources of rock, we're now able to extract. So that has increased the amount of oil available compared to earlier estimates. Political factors can also be important. In the United States, there's long been a battle between environmental groups and oil extractors. Is it okay to drill offshore now in many places? There's ongoing battles in places like California or Florida, or indeed in sensitive ecological places like in Alaska. And in other places in the world, political uncertainty might mean that drilling doesn't occur at the same rate that you might expect. Economics is another important factor. The price of oil was low for a very long time in the 20th century, but it has recently spiked. In fact, it's as high now, in relative terms, as it was at the start of the 20th century. So this means that if oil is worth more, then places where it's more expensive to extract are now economically feasible. So places like the Arctic or deep water sources or unconventional sources. So oil producers can now make money extracting from reserves that used to be uneconomic. This brings more reserves into play and can extend that period in which we are at the peak of oil production. Classically, we think of oil as just gushing out of the ground. But there are other types of oil, for example, oil sands, where the petroleum product is mixed in with minerals and much harder to extract, and it's more expensive to extract. But with these new prices, it's worthwhile. Oil sands are found in places like Alberta, and so there's been a big increase in the amount of extraction of this supply. A few years ago, it wouldn't have made economic sense, but with current oil prices, it does. If peak oil is true, we would therefore expect reserves to be declining as they are exhausted, but we're not actually seeing this in the world right now. In fact, in many places, reserves are coming up a little bit as these new unconventional sources are included in the totals. The US federal government, for example, says that US oil reserves are higher now than they've been for a number of years. The Society of Petroleum Engineers is estimating that we have around 40 years of use at current rates. This number hasn't changed since the start of the decade. Other estimates include 46 years, and in fact, Saudi Arabian authorities have estimated 80. And these are probably lower estimates. If the price of oil continues to climb, then more and more unconventional oil sources will become economically feasible to extract. So this means that places like Alberta with oil sands will see more and more activity. And as you can see from this pie graph, these sources of oil are actually very significant. This means that we might have enough oil to supply our transport systems for most of this century. But of course, this ignores the impacts of climate change.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.